In earlier lessons, we learned about three major challenges related to deploying 5G networks: high bandwidth, massive connectivity, and low latency. Today, we will learn about a fourth challenge: operation and maintenance (O&M) of 5G networks. Mobile services have developed rapidly over the past 20 years. Early on, mobile services consisted only of voice and text message services. Now, mobile services are constantly evolving, with an exponential increase in mobile service provision. At the same time though, network operators' revenue has been declining, and their average revenue per user has been decreasing non-stop. To increase operating revenues, many major operators are working hard to offer new services. For example, operators are starting to get involved in emerging industries, such as telemedicine, WTTX, and IoV. The increasing abundance and diversity of mobile services available to users presents two major challenges to network operators. First, O&M costs are increasing because average monthly data traffic per user has been steadily rising, making networks vast and unwieldy and leading to a need to constantly expand network capacity. Second, high-quality video services demand ever higher network speeds. The large number of Internet of Things connections are placing higher demands on network connectivity, and self-driving vehicles have increasing demand for lower network latencies. Network management is also becoming more complex because different services have vastly different quality and optimization requirements. In the recent future, networks will become multi-RAT and multi-band. Multi-RAT refers to networks simultaneously supporting 2G, 3G, 4G, and 5G. Multi-band means that networks will support the simultaneous receiving and sending of wireless signals on different frequency bands. As networks continue to develop, single macro base station is already no longer able to meet service requirements. Huawei has introduced a heterogeneous network, or HETNet, solution to deal with this problem. This solution is composed of a set of base stations, including macro base stations, small cell base stations, and micro base stations. HETNet allows operators to precisely deploy layered networks based on their actual traffic distribution. Macro base stations can be used to provide continuous coverage over the entire area, while small cell base stations and micro base stations can be used to provide seamless coverage in hotspots and blind spots. A multi-RAT, multi-band heterogeneous network would be an extraordinarily complex network. This complexity arises from having to coordinate base stations to achieve seamless coverage and have to control interference between cells, among other obstacles. As a result, network maintenance has become increasingly complicated and operating costs are continually rising. For example, the introduction of high-frequency, ultra-dense networks and massive MIMO technology would lead to increases in the difficulty of site operation, maintenance, and optimization. Massive MIMO is a remarkable technology. Actually, massive MIMO is an adaptation of a military technology called phased array radar for civilian use. Massive MIMO can intelligently adjust antennas in multiple ways to optimize coverage in a way that would be difficult for humans to do. O&M personnel's roles will shift to analyzing application scenarios, then, based on that analysis, setting rules for the algorithms. In the future, algorithms, rather than humans, will determine and execute coverage adjustments. "5G networks will help set up an Internet of Everything. But different services within this larger network will have different network requirements. For example, the many sensors used in the Internet of Things industry have extremely high network connectivity demands, but do not necessarily need high transmission speed or low latency. In contrast, autonomous driving services place high demands on networks to have low latency to guarantee safety. VR and AR services need networks to have high bandwidth to provide a good service experience for users. The autonomous driving networks, AR and VR networks, and Internet of Things that we will need in the future are different logical networks, or network slices, as they are often called. When all these networks are running together, network management is not about managing one 5G network, but about managing different network slices. Network slices require a cloud-based network infrastructure, which increases O&M difficulty. There are many considerations when thinking about how to guarantee network slices quality of service, or QoS. Coordinating between network slices on radio access networks, or RANs, bearer networks, and core networks allow the creation of logical E2E networks that can support different service scenarios. However, functional optimization of network slices in specific service scenarios and network customization based on different industries' requirements can only be achieved through automation. If operators were to rely on maintenance personnel to conduct this optimization and customization manually, efficiency would be too low and cost too high. Furthermore, the networks of the future will be cloud-based. Operators of cloud-based networks will face the challenge of operating and maintaining layered networks and requiring maintenance personnel that have advanced IT skills. Ensuring that 5G network-based services are quickly launched requires fast deployment of network equipment. How network equipment can be deployed, configured, and connected quickly is a question worth considering. Meeting the specific needs of new services requires deploying network equipment with the corresponding specific functionality. However, one functionality can have hundreds of parameters. Configuring these parameters manually is not efficient. How network equipment with specific functionality can be deployed quickly and accurately is another question worth thinking about. When there is a breakdown that needs to be dealt with urgently, some time is needed to find a final solution to the problem, beginning with front-end monitoring personnel discovering the problem, then having back-end staff analyzing and determining the problem. How network malfunctions can be dealt with quickly and network functionality restored swiftly is yet another problem worth keeping in mind. Agile and intelligent network O&M is needed to ensure that network services can be launched quickly. This is another challenge for operators. Networks currently rely on personnel to conduct O&M manually. This increases the time needed for network planning and deployment. For example, launching VoLTE networks requires several months to a year. Manual network maintenance and optimization is inefficient and increases O&M personnel's labor intensity. For example, when there is a network malfunction, manual network maintenance would require workers to collect information about the malfunction and spend a lot of effort on analyzing the problem in order to deduce its root cause. After inferring the possible origin of the problem, they need to spend more time on solving the problem step by step. At times, near-end maintenance engineers need to coordinate with back-end maintenance engineers before the problem can be determined. In cases in which there is a complicated problem, resolution of the problem will take a long time, which negatively affects user experience. If there is a need for urgent optimization, handling the issue manually would take a long time, as it is a challenge to manually respond to such optimization requests quickly. Current network services mainly provide voice and data services and are mainly aimed at serving people. People's requirements for voice and data are mostly the same. Voice services should allow people to make calls whenever they feel like, without any noise interference or dropped calls. And data services should guarantee bandwidth, ensuring that videos do not pause for loading, among other requirements. As such, current networks' O&M models are relatively unsophisticated. In contrast, 5G networks require more elaborate O&M because they have more diversified service scenarios, connect a more disparate set of devices, and serve a more mixed group of client industries. We have already started researching and testing self-organizing networks on 4G networks. We need to continue these explorations on 5G networks to ensure that O&M of future networks is more automated and intelligent. This lesson has mostly discussed the changes the rapid development of 5G services is bringing to network O&M. 5G networks present three major challenges in terms of O&M. Complex networks, which result in continuously rising operational costs. Service diversity, which results in network management becoming more complicated. And the need for quick service provision, which requires agile O&M. Current networks O&M models cannot meet future networks requirements. Future networks will require integrating O&M platforms with tools, big data, and artificial intelligence to achieve automated and intelligent operation and maintenance. This is another new challenge posed by the deployment of 5G networks. Adding the challenges of high bandwidth, massive connectivity, and low latency requirements, which were discussed earlier, we have now discussed 4 challenges related to 5G network deployment. How will the industry deal with these changes in deploying 5G networks? In the next class, we will discuss the transformations that 5G networks will bring about.